Well, Russell is finding his way, and I will let him in if he turns up, and I will manage him in if he doesn't. So let me introduce people. Like I say, it's very important we do this. Dr. Gustav Borgefalk. It's great when you've got your doctorate and people call you doctor a few times, and then they forget and they call you Dave or John or Nick or something entirely inappropriate, usually in my case. I'm going to read what I wrote on the website just so you get the same consistent story. Gustav recently completed his PhD in service design at the Royal College of Art in London, runs a venture studio based in Stockholm, Sweden, working at the nexus of design and innovation, co-founder of Katla Aero, a manufacturer of electric aircraft, and House of Education, a software as a service company, which develops digital recruitment platforms for higher education institutions. Gustav also holds an MSc in Business Administration Operations Management from Stockholm School of Economics, diploma in Exponential Technologies from Singularity University, an advisor to Stockholm School of Entrepreneurship and to several early stage startups. He paints, builds stuff, and these are his words, not mine, and destroys his joints by playing football, which has an admirable combination of things apart from the football bit. If nothing else, extremely busy. Gustav is going to talk about design cybernetics as a language for service design. I'm not going to tell you any more than that because he knows his material far better than I do. So Gustav, I'm just going to hand over to you at this point, give you 30 minutes from now or thereabouts. And so over to you. How about that? You can share your screen when you're ready.
All right. Thank you, John. Thank you for that kind introduction.
Can everybody mute themselves that isn't Gustav, please?
There we go. Does it work? Yes? Yes, super. Great. So again, thank you very much for the invitation for sharing my research. The past 4 years have been weird. Started out very sort of happy to get going with my PhD in London. And then the COVID the pandemic came along, and I got to spend most of it at home, and also defending the thesis online, which was an interesting experience. But I think that I want to consider this a trailer for my dissertation, and I hope that I think that you will recognize most of the concepts, the things that I will present here, but hopefully there will be some new things to take away as well. A bit of a smorgasbord, if you so will. Since I haven't met most of you in person, I just wanted to share a few few words about my background. As John mentioned, I spent 10 years roughly working with different startups, developing different kinds of services prior to starting the PhD. I did a master's in business administration at the Stockholm School of Economics, and then I did the PhD in design at the RCA. So I didn't have a design background before starting on the PhD journey. And also, I didn't know about cybernetics until I started the PhD work. So the past 4 years has also been a venture into this wonderful world. Yeah, and also I run a venture studio, and right now I'm working on the aircraft that you can see up on the right hand side, an electric vertical takeoff and landing aircraft called Katla. It's just a lot of fun working not just with intangible digital services, but also with physical products. But my dissertation concern digital services mainly. And the overall argument is that design cybernetics is useful as an approach to the design of persuasive service systems. And this is a mouthful, so I'm going to unpack this a bit. And the service systems, well, digital services, as you know, we're spending more and more time using digital services or outsourcing part of our sort of thinking, our cognitive agency to these different devices. But the benefits of the approach that I would argue is that design cybernetics can expand the language of service design when it comes to designing persuasive service systems. It can also make cybernetics and second-order cybernetics perhaps more useful in service design practice and contribute to increasing, well, performativity of cybernetic research. And what I mean with that is that if we go back in history, cybernetics was, well, it was, and first-order cybernetics in particular had this performative component, the colloquy of mobiles, the tortoise, and the things that that were so characteristic of cybernetics in the past. But now that we are moving to a world where sort of design is more concerned with services and systems, these performative components are perhaps more difficult to identify. Service design is a subset to design and design research. And while the sciences, I prefer the definition of design provided by Herbert Simon, which stated that science concerns what is and design concerns what could be. So this forward-looking sort of exploration into things that could exist, bringing these things into the world and strategies of making things, creating things, working with the future, that is at the heart of design. But what's happened in the past century or so is that the design subject has moved from being focused on handcraft, on things, on physical products, on buildings, architecture, to service craft, where services and systems are more in focus in design practice. And the difficult thing with the systems and services is that they're intangible. So that on the image here, you can see an example of a journey map, like an attempt to capture the systems. Like how do we describe these systems that are that we can't see? That is one of the struggles of designers and design research today. W.M. Pangaro highlights a couple of other aspects that differs service design from product design, that it often takes place in teams, and that teams needs a coherent language to communicate. They're immaterial, but also there is a complexity that needs to be described. And different actors need to be able to talk about what's behind the scenes, behind the shiny interfaces of the digital services that we consume today. There is a growing complexity that we need to find communal language to describe. And my thesis focuses on a particular type of service systems, which are called persuasive service systems, or persuasive systems for short. Roughly 20 years ago, B.J. Fogg laid the foundation to the field of persuasive technologies with his PhD thesis on charismatic computers. He started looking into the idea that computers, or when you persuade through a computer, with the computer as a medium, it has impact on the types of persuasion that it enabled new types of new forms of persuasion. And the Captology Lab had quite, and it's still around. It has had a fairly successful run. There are several models that came out of the lab. Was also the foundation of some of the more popular modern services. One of Instagram's founders, for example, attended the Captology Lab at Stanford. a capitology that's short for computers as persuasive technologies, where the focus is, it has a background in human-computer interaction and in the information systems. And the field is largely sort of shaped in that tradition, although it's an interdisciplinary field. But the focus of persuasive systems is the intent to influence people's behaviors and actions that is embedded into a technology, that is sort of embedded by a person, a group of people that are using the systems to enact their agency in the world. And this effectively makes these systems goal-oriented, where the intent or the change that these systems propagate is embedded into the structure of the digital systems. And this includes, well, for example, social network services that we use every day, e-commerce services, video content, games, etc. That all have intentional behavior influence on people's behaviors or attitudes at their core. An example of a popular e-commerce site, Amazon, is that the intent of different components on this site and the reason why the choice architecture or the architecture of the site is dynamic and is adapted to personalize to whoever visits the site is, of course, that the site wants to persuade us and drive us towards certain behaviors, whether it's to click in certain places, to buy certain goods. That's an example of how the system sort of is designed to influence us. But as computers become more advanced, sensors become more advanced, and new and more qualitative data can be collected on human behaviors. These systems also become more complex, but also more difficult to understand, and to a point where where you could say that they're unknowable, and this leads to a number of problems that can also be described as wicked. Pangaro has listed a few of them, which you probably recognize, like the risk of algorithmic bias, using digital media to manipulate attention, to manipulate political attitudes, so-called dark patterns and deceptive design are problems that are proliferating in this sort of digital jungle that is emerging. And these aren't sort of problems with with binary solutions that can be fixed, or but it's rather a matter of taming these systems and also taming these wicked problems to reduce their impact and to see how we can reduce their negative impacts on society. What we also see is that the interfaces are becoming more advanced. An area that I find really interesting is anthropomorphic interfaces, or human-like technology. That's where we're reaching a level of fidelity in video and audio, in the synthetic video and audio production that is that makes the digital almost indistinguishable from the real thing. There are new types of sensors like the brain-computer interfaces, also facial recognition, affective computing, etc. That is also moving from research labs to more mainstream consumer services. And all this together presents more advanced sort of persuasive opportunities for anyone who wishes to influence another person or group of people through technology. But if these service systems can then be understood as cybernetic systems, as goal-oriented, purposeful systems, it makes sense to explore both the cybernetic and a second-order cybernetic approach to their design. design cybernetics is a subset of, or a subset, but it's a branch of the cybernetics and second-order cybernetic studies, focusing on the overlap between design and cybernetics. Ranulph Glanville, he described cybernetics as a language that has the potential, well, not just a language, but as a theoretical arm of design, and that design could be the practical arm of cybernetics. And some scholars that have embraced this perspective and that's contributed greatly to that view, apart from Glanville, Klaus Krippendorf, Hugh Dubberly, Paul Pangaro, Ben Sweeting, Fisher and Herr, who published this book a few years ago on design cybernetics with a collection of essays. Also Joy Ito of the MIT Media Lab have expressed, the former director, expressed several ideas connecting design and cybernetics in his manifest for how the lab should operate. And at the RCA, in recent years, design cybernetics has been taught as a foundational design research perspective. So that's how I picked up design cybernetics, or was introduced to it. But there's been several other PhD theses coming out of RCA as well. For example, Tibor Balint's space design research thesis, and the Delfina van Ditmar's second thesis on second-order cybernetics and IoT devices a few years ago. So at the RCA, cybernetics and design cybernetics is very much alive at the moment. And Professor Ashley Hall, who is head of the research program, is one of the driving forces at the college behind that. And what makes design cybernetics particular is, and the relationship between cybernetics and design, is the circular conversational process. In design, this circular process of sort of when you make things, that's like observing the things you make, you see what happens, and then that changes your mind, you reflect on the making. That Donald Schoen also described and denoted reflective practice. That the role between the observer, the designer, and the thing that is being designed is very much in focus of this design theory. It's likened to a conversation between the designer and the thing that he or she designs. A conversation not necessarily between two people, although it could be a conversation between two people. But it could also be a conversation with a material, with a text, with an environment, a place, a building, or a system, and so on. And this is where the overlap with the cybernetics. And another area in which this overlaps is the meta design aspects, i.e. designing design, doing research on design, or the context in which design emerges. And not only exploring the designer's role and the role in design, but also their value properties, whether a design is good or bad, for example, and who gets to decide whether a design is good or bad. And another aspect is of course how second-order systems influences, in the sense that they govern, regulate first-order systems. That can also be reflected in the design process, where the thing being designed can be seen as a first-order system, and the designing system, that's part of the second-order systems. And when I think of this, I think of observers with intents. That perhaps that is a subset of, perhaps that is an aspect of this observing the observer paradigm that comes with second-order cybernetics. When the observers essentially become agents that pursue their goals through the things they design, in the philosophy of persuasive systems. And a few other overlaps between design and cybernetics is in the conversational approach. And the conversation in the cybernetic sense versus the conversation in design sense are essentially the same or very similar processes. That the designer is responsible for her position as an agent in a system, recognizes that the designer has a power to influence not just what is brought to the world, but also how it functions. But that there are several benefits of this conversational approach that is emphasized by Dubberly, Glanville, and Sweeting. For example, that the values in the conversational process, in the process of making in these conversations, values are made explicit, they're shared. It implies listening. It also implies generosity, honesty, neutrality, open-mindedness. Like these qualities that are at the very heart of design are also at the very heart of second-order cybernetics. And Dubberly and Pangaro expressed this well in 2015, where they wrote, if design, then systems, if systems, then cybernetics, if cybernetics, then second-order cybernetics, if second-order cybernetics, then conversation. Okay, so that was a bit of background. Now, what did I do? I think I have a few minutes left, right? Super. So based on this literature review that largely focused on the relationship between design and cybernetics and second-order cybernetics, I developed a method to answer the research question, which was based on conversations, and essentially two types of conversations: conversations with the self, that is reflective practice, and conversations with others, where I went out in the world to discuss concepts and do live projects with other actors to test my thinking. And this can be seen as research through design and research for design, i.e. through design and designing, the act of designing, creating new knowledge, and for design, for designers to use in their work. And in this in the intersection between these two modes, like shifting between these two modes of research, like getting into my cave, sort of experimenting, researching, testing things, and then trying out these ideas in the real world, then new knowledge was created. So one of the first things that I tried to wrap my head around was, okay, so what design cybernetic concepts are there? Like from my perspective, like which concepts are there? And just trying to create a map of the landscape, sort of different patterns or concepts that's found in literature. I've tried to get as many concepts as possible in there, but this is, of course, by no means an exhaustive collection of concepts, but it's well, it's a collection. It's my collection. Next, I try to figure out, like, okay, so given that all these concepts exist, how can these concepts be used in service design of persuasive service systems? And so, for example, the concept of variety or requisite variety is a brilliant concept, of course. And there's all these situations when you design services where variety and requisite variety comes into play. Both when you're, for example, assembling a design team, trying to figure out which are the right competences to have in this design team in order to meet all the challenges that this service will face when it gets out in the real world. So, for example, if you're putting together a design team at a company, but you don't have, say, ethics competence in the team, well, then you need to have that in order to meet with the ethical requirements on the service down the road. but it could also be used, for example, to create resilience in systems, to develop services that are more resilient to changes in the environment, and to analyze how these systems can be made more resilient. So I started matching sort of patterns from the design process of service design with the cybernetic concepts. And in my reflective practice, I also service concept, like develop different touch points or parts of services where I used the where I use these concepts as inspiration, trying to figure out, okay, so if I'm creating a touch point that has this or these, or that's supposed to do this or that, perhaps this concept can be brought into play here, perhaps this concept can be brought into play here. So that this was, I call this epistemic service design, in a sense that it was not service design to answer a brief from someone, which is usually the case when you're a designer, that you get a brief from someone and then you start working on it, but rather a service design process with the sole purpose of developing new knowledge, which we were sort of led more by curiosity and an explorative approach rather than to answer a brief. And it resulted in a kind of a course or a collection of concepts with a concept for a course in design cybernetics that can then that had interactive components, which one could then sort of use as a designer to dig deeper into topics and then connect that to a digital backend. Yeah. Anyways, you can read about it in the in the thesis. And in the external dialogue, the conversations with others, I engaged with one of the oldest anti-bullying organizations in the world, Friends, who were curious in exploring new forms of touch points for their service offering, and the touch points in the form of cyber or physical touch points that they can embed in digital or physical environments and have conversations to address cyberbullying. And another case study, I worked with Planathon. That's a design business development studio focusing on sustainable planet-centric design, where I explored the relationship between different levels in different cybernetic service levels. So we developed a service together with 3 student teams at the RCA, where they designed services, and it was reflecting on like how first order cybernetic systems, second order cybernetic systems in the context of a design team, how they interplay and what is to be learned from organizing these contexts in which other people design in a way. So what came out of this exploration? Well, the question that we got from the beginning of the journey was, how should one design differently after having sort of read your research? And I think the main takeaway is that the self-reflection part, understanding your own agency as a designer in a system and observing the observer in that sense, that is a key aspect that is often overlooked in service design and also in service design education. That there's a lot of focus on the thing that you design, the service that you design, but there is less focus on the designer and how you and what you as a designer brings into the design context and to the things that you design. the other important aspect was that to consider design as conversations, that has several benefits to it, not least to embed some of the ethical qualities that were listed on a previous slide. Both to have the conversations with oneself ongoingly, to reflect, to do diaries, and to really reflect on your role as a designer, to think of your interaction with materials and systems as conversations of situations of mutual learning, where you're learning and you're also educating, and how this approach can address these problems with persuasive service systems is, well, essentially shifting the focus perhaps from the symptoms, because the dark patterns and the symptoms that we see in the digital services today, that they are essentially the symptoms, but not the source of the challenges. That a lot of critical challenges in with digital services lies in the second order domains, in the meta design level. So we need to start working with with meta design of persuasive service systems, essentially. And second order cybernetics is a great language to start discussing some of the challenges in the meta domains of design. And by exploring services from that perspective, the questions of values, ethics, and goal formation, purpose, or who embeds the purposes into the systems, that gets more attention than the actual functionality of the platforms that is what we see.
About 5 minutes, Gustav.
Okay, that's great. It's I have 2 slides left. Thank you. I think that Jocelyn Chapman put it really, really well in 2019, that she wrote that by changing how we think, cybernetics transform how we behave, and thus increasing possibilities for positive systemic change. And that sort of ties back to the designer as reflecting on her own position, like and at least, I mean, that's my takeaway from this journey, is that by exploring cybernetic concepts in the context of service design, which is sort of my practice, what I practice when I well, at work and as a designer, it changes. So it first changes how I think, then it changes the way that I make, and that in doing so, by that in turn can have positive impact on the things that I design. But what's also needed, and I think this is the exciting part of it, is that, well, that second order cybernetics in particular is it's a fairly theoretical area, and it's been criticized in recent years for being perhaps too theoretical, that it's difficult to perform second order cybernetics in the same way that first order cybernetics was performed in earlier days. But digital services, that's where design takes place today, largely. That's a growing area in design, and it's also an area where there is a great need of innovation, a need of new methods, a need of new design methods, where second order cybernetics could really do some good. If I want to leave you with one thought, is that, well, perhaps, I mean, exploring further second order cybernetics in the context of service design, and perhaps also in the context of designing persuasive service systems designed with the intent to influence people's behaviors, that could be an arena where second order cybernetics could tangibly, practically do a lot of good. Yeah, so I think I'm going to round off there. Thank you so much for listening to my incoherent rambling. I must admit I was a little bit nervous as well. This is the first time I presented this after I've graduated. But so thank you so much for listening, and I look so much forward to your questions and feedback.
Brilliant, thank you, Gustav. That was excellent. So the way that the format of these things is that we don't take too many questions at this point, maybe one or two for clarification, and then we'll hear the second talk from Russell at IBM, who eventually managed to break into Zoom, whereafter we will then have a much bigger and richer conversation. Hi, Russell, welcome. Glad we beat Zoom eventually. So I'm going to ask one very explicit one from me, which was, because that was a really good, and I'm captivated by lots of it, and sitting here thinking I need to go back through all those slides and really start to think about some of the things you said. You're not explicit about the issue of power, either in the sense of political or the power of rhetoric in particular to change or distort the conversations which you talk about so eloquently. So I just wonder whether that's something you want to comment on.
Absolutely. I mean, I think power is at the heart of the issue of persuasive digital systems that are supporting people. I mean, before we started living our lives mediated by technology, I mean, or digital technology, I should say, we've always lived with technology as tools to enhance our agency in the world, whether it's a spade to sort of dig, to move Earth around, but these cognitive tools that we're using these days are powerful amplifiers well, both analytical capabilities, but also of our ability to act and to influence other people. So that, and as we spend more time in this, with our decisions formed in and by the digital technology, the power of the designers of that technology also increases. So that, and I think chatbots is a great example that we're spending more and more time interacting with chatbots. There are more and more chatbots out there, and somewhere behind all these chatbots, there is a poor service designer trying to figure out how to handle every single situation that chatbot is exposed to. And we also know that when the chatbots are first launched, the first thing that people do is to try to break them, they humiliate them, they abuse them, which opens for so many new issues that that ends up on the designer's table, but also issues that can impact millions of people. Like if you just change a few lines of code in Twitter or in Instagram, it impacts the behaviors of millions of people. So when discussing power and how power is sort of the power to influence certain decisions are definitely in the hands of those designers to a larger extent. And we can just, I mean, when we schedule a meeting using Teams or Zoom or our favorite calendar apps, whether the meeting is 15, 30, 45 minutes or an hour, I mean, depending on what that menu looks like, that impacts the behavior of, I mean, and also it impacts the lengths of billions of meetings, which is it's a design thing. Like if you, whoever said that a meeting should be 15 minutes and coded that into the calendar software had the power over, well, 95% of all meetings in the world, because you choose the default, right? You choose whatever is the default if you don't know what to choose. So while designers on one hand try to help us navigate this increasing complexity, they also make decisions for us to a much larger extent. So yeah, sorry, that was a long rant.
That's fine. So, yeah, the thing that wanders around in my head is the extent to which the designers of such systems exercise power over us as users, of which we're completely unaware. We don't articulate and make explicit those things that actually start to condition our lives in quite profound ways. I was talking to Peter Kavalek at Loughborough earlier this afternoon. He was telling me about a self-driving car he was using yesterday, which decided which lane he ought to be in without bothering to consult him. And that's a decision made by the designer of a piece of software, somewhat remote from where he is. So very quickly, so Rory, you've got your hand up. If you want to come in with a quick question, and then we'll start to move on.
Forgive me for asking an extremely simplistic question, but I'm new to cybernetics. Could somebody define the difference between first order and second order cybernetics for me, please?
Right, well, we'll get Gustav to answer that since he's used the language so much in his session. So go for it, Gustav.
Thank you.
It is your interpretation, not anybody
you.
else's.
Yeah, thank you, Rory. Thank you, Rory. That's a great question. So first order cybernetics, I like to. It's an example that might be a bit worn by now, but if you consider a thermostat as a first order cybernetic system, a thermostat is set to say 20 degrees, and it constantly senses changes in the environment, and it adjusts the temperature, so that it can regulate the temperature in the room so that to keep it at 20 degrees. And it does so in a circular manner, so that it tries to keep the temperature constant at, say, 20 degrees. That's the goal of the first order cybernetic system, a mechanical system. The second order cybernetic system is when you consider who is setting the goal for the thermostat, who is programming the thermostat, and what are the underlying sort of, it's a second system in a sense that is controlling the first order system. And that system can also be a cybernetic system in the sense that that can also have a goal or a different goal, but that it tries to influence the first order system to operate in a certain way, that it regulates it in a sense, or controls it, whatever word you want to use for it. I'm not sure if that was a good analogy, but it's a I think when it comes to design, I mean that's the mechanical example, which is it's tangible and it's more. I mean, you can envision this mechanical system and you can see someone sort of turning that knob, but the same logic can then be applied to a design system, for example, where goals might not be as clear as 20 degree on a thermostat. It could be that it's a political goal, a cultural goal, a goal with a design, that you want to design something that has certain qualities or properties, for example, or a in my case, a service system that is programmed to achieve certain persuasive goals. A service that wants you to click on a cat video, for example, 100 times. I mean that's if you design a service to have us click more cat videos, well, then that's the goal of that first order system. But whoever programs that goal into the first order system and controls that goal, well, then that becomes the second order system. So then there is a whole debate about higher order systems as well, which I can't go into it. But I'm sure that there are lots of other definitions as well for first and second order.
Rory, we'll come back to that one, Rory, next time we're having coffee at an unsuitable hour of the morning for you on campus in the next couple of weeks, sometime soon, because we do need to make progress. So Russell B has defeated the designer of the Zoom system, who created a system that was designed to keep him out, and has managed to get in. And we did that by changing the information flow, which is a sort of interesting place to start. So delighted to welcome Russell, who I've known for, I don't know, a few years now. We met at Manchester Business School when talking to various groups of students a few years ago. So Russell is an IBM STSM, which I'm not entirely sure what that means, Russell, but I'll let you explain it, and product manager responsible for the IBM Maximo Oil and Gas and Maximo Health, Safety and Environmental Manager products. Leading work on new developments for role-based applications and sustainability, works closely with the worldwide IBM customer base to identify common customer requirements and build these into products. An engineer by training, but we won't hold that against you, Russell. Spent 10 years in the aerospace industry, working on aircraft systems design before joining consultancy, working on systems engineering and the implementation of plant control systems. BSc in aeronautical engineering, MSc in electronic engineering from Salford, MBA from Manchester Business School, and is a visiting fellow at Loughborough University's Centre for Information Management. Russell is going to talk to us about realising business value. So Russell, welcome. Thank you for giving your time tonight. I'll start the clock and the floor is yours. You should be able to simply share the screen. You can. Excellent. Thank you.
Yeah, it's working. And with a bit of luck, I can put it on full screen as well. One second. Now, Zoom is just defeating me for 1 minute, John. So
you probably have to unshare and then
yeah,
reshare.
I think I've got there. Yeah, great. Okay, thanks for the introduction, John. So yeah, this presentation. So quick explanation of STSM. That's a sort of an IBM designation for a technical leader within the development organization. So we sort of have, IBM is quite good in having technical career paths for people as well as a management career path, and that's my side on the technical path. So
you appear to have turned your video off, Russell.
Yeah, that's interesting, isn't it? How's that, John? Is that video working now? Great. Yes. So I work on building software-intensive systems, and in the area of enterprise application software. And I'll just, by introduction, just tell you a little bit about the system I work with. But from the perspective of the previous presentation, which was a very interesting listen for me. So I work with a large team of people around the world building enterprise applications, hundreds of us involved in the development of this software, and a large design team. So we're in constant side-by-side working with our design and applying design thinking principles to the development of our software. So it was really interesting to hear that design viewpoint, and also the illustration of first and second order systems. And I sort of have just a slightly different view of that as part of my presentation that we'll get to towards the end of it. So there we are. Zoom is going to allow me to move. So Maximo, and I don't want to spend too much time on Maximo. This is not a pitch for Maximo, but just to give you a little bit of the context of the following slides. So Maximo is a system that supports the implementations of customers' business processes in the areas of maintenance, reliability, and operations, safety, and it's built around customers who have asset intensive industries, and also I guess there is it will support customers with who have service-based industries, generally working with asset intensive customers. It's an integrated suite of solutions, as you can see, very many different components of it. It's been built up over a history of 40 years now. Big complex application. We try and keep the user side of it as simple as we can, but behind the scenes is a very big piece of enterprise application software. And essentially it's a system that helps our customers take action, and it manages the processes and tasks and procedures to get things done. So if we think about action, this is something I was introduced to Chris Agaris from as part of my work when I was at the Manchester Business School, and taught by Peter Karolek. And I like this definition of effective action. I found the work, Chris Agaris's work, very engaging about the definition of the effective action being the fundamental objective of human and organizational performance, and that definition of action, to the extent that it's consistent with intent and it persists, I think is a really interesting definition of action. And I'll come back to Chrysagoras a little bit later in my presentation. So I should emphasize that I'm not an expert on cybernetics, so I sort of tend to come at it from more of an engineering viewpoint, for the feedback mechanisms, and draw my analogies there. So think about the automating business processes. So a lot of our work is around delivering these business processes and how we automate them. And starting point is the current state. And there's a screen, sort of typical form-based screen from one module of Maximo. And so I think this is still fairly typical of most enterprise systems, that there's a lot of manual human input required. And I think it's fair to say that we get, we hear from customers that they spend more time than they would wish to on routine repetitive activities, and that sort of hinders them spending time on things they really want to spend on. But it's but often customers working with these work management processes, safety related processes, they just are dealing with very large quantities of data, lots of work orders. A big customer in an oil company would be, they're generating hundreds of work orders a day, generating across a large organization thousands of service requests, incidents over a relatively short-term period. So lots of data to deal with, and it's very often being dealt with through human interface. We do a lot of work with mobile applications to simplify the UI through a mobile device, but still to an extent there is quite high levels of interaction with the device, whether it's mobile or on the desktop. So we very clearly hear that users want to spend more time on value-enhancing work. How do we generate value to spend more time generating value to the organization and remove some of the frustration of dealing with these routine activities? So we provide automated workflow capability to support a level of automation, and clearly improving the level of automation is a way forward. But those automated workflows of the business processes themselves can often require significant human input. They still come back to a human for a decision. They're sort of routing information through the system a little bit more smoothly. They can get quite complex and hard to understand in the when you really go for high levels of automation. And so they're not really a complete answer. They're a very helpful tool, but they're not a complete answer to support customers getting their work done. So we've been spending a lot of time looking forward as to how we can make use of the of technology to improve that. So in a digital era, then automation provides the opportunity to deploy technology at scale. And I think where the AI side of things comes in that the AI has the capability and the potential, and it's still potential in some cases, to accelerate and further scale automation. So from our viewpoint, when we're looking at AI, it's the engine to scale automation. Some of the areas that we're looking at here as to how we can deploy that AI-powered automation. So, I mean, where is AI strong? In collecting, organizing, and classifying vast amounts of data. It's clearly, if you think of an example of, a typical example would be, think about the amount of work that might in an electrical utility, going and inspecting all the overhead lines in an electrical network, looking at the condition of the insulators on those lines, been a very manual activity. You can use drones to speed up the inspection process. Those drones themselves actually then bring in large quantities of data. But this is an area where AI and sort of neural network technology has been proven to really be good at being able to differentiate and be trained and be able to train and identify issues that are hard for a human to detect. That would be a good example from a data perspective. Help with, from a process mining perspective, identifying where automation can boost performance. So looking into the system, looking into the data system, and then being able to find areas where it's not always completely obvious that the system is not performing as it would do. So that's sort of where the mining side of things come in. Being able to support I guess this third bullet ties into the deliverance of effective action, and provide that insight into the data. So not just be able to classify data, but be able to provide insight into data, look at recommended courses of action. So you've sort of got graded levels of the level of capability you can obtain from using AI. And if we sort of look at this from a technology perspective, then look at these three pillars here from the process mining perspective, intelligent workflow and robotic. And interesting, earlier we sort of Gustav started to get in that interesting discussion about bots and where you can best apply them. And it's a very active discussion, and we've been involved in the deployment of trying out bots from a sort of a business process perspective rather than a consumer application perspective, looking at how we can introduce a bot into the process and using sort of some of our IBM Watson technology, and being able to train them and think of the appropriate use cases is a major design task, as Gustav highlighted. But to the left-hand side in the process mining, so process mining has the potential to, there is a lot of opportunity and the identify to I mean, you can do that at a basic level with simple sort of just using a business process workflow tool. So you can do some of this manually, but where the process mining comes in is when you're gathering large amounts of data and you're analyzing. If you think of some of our customers who have literally got, in terms of their maintenance organizations, millions of work orders, then you don't easily go through millions of work orders to detect subtle trends in those work orders using a manual business process automation tool. So the potential of the mining to look at those very considerable amounts of data is a really strong one. What we start to also see though there is, if you're dealing with large quantities of data in enterprise applications, data quality is always an issue. So we don't live in a perfect world in terms of data. And if you're going to train AI models, of course, some of these models are very data intensive. So in itself, the capability is there to come up with some really interesting things, but you also have to think about the amount of data required to train to get some value out of that, applying that technology to your business process. So that's not necessarily a simple thing to do. And the other thing from a process mining perspective is those subtle differences are very customer specific. So from our perspective, in terms of building common enterprise applications that can be used by customers in a whole range, with thousands of customers worldwide in a whole range of different industries, it's quite actually difficult to come up with common models. And of course, some of that also is a customer secret source as well, in terms of the training of those models. So in some cases, it's perhaps more appropriate that some of that technology is applied as a service effort rather than embedded in the software. And for us, you know, it's a very attractive to be able to introduce that capability into our software in a way that's effective and easy for customers to use, and can work with a sort of the appropriate quality and level of data that we typically see in our customers. So it's a very attractive area in terms of what you can potentially do with it, but it comes with a relatively high overhead, I would say, with the current state of technology. It's an area we continue to look at very closely. But one of the things I think, if we look at the intelligent workflow side of things, where perhaps in terms of the first steps into AI is where we've focused our efforts, and this concept of a digital worker, a digital assistant, and we tend to refer it as digital skills. So we have sort of almost a skills engine that you can train to do certain routine activities. So if we think about those pain points we hear from our customers, so doing the routine activities, that might be approving something like a service request or a work order, when you're just making a decision on whether you're going to go ahead with that work, whether it's an appropriate thing to do. The sort of there is what we see as clear opportunities, and this is an area we're already working in, and is to be able to provide an assistant that doesn't necessarily deal with and doesn't have to deal with every combination. But if you can have a digital worker that can take some of that routine activity and carry out those tasks in a way and collaborate with the human in the loop, who is perhaps going to want to look at some of the things that are exceptions, or particularly have some sort of regulatory inputs, and then the assistant can be trained well enough to know what they can and can't do, then that area gets interesting. And from a sort of a broader application software perspective, those processes can be quite common. Generally, we require less data to train them. Give us the capability to have pre-trained models that we can tune up at a customer without large amounts of data, but we can sort of add value through embedding the AI into the workflow. So I think this area of digital workers is a really interesting one, and is sort of the most immediate potential. And we've been working for a while now, training to. So one of the things that in a lot of our customers find, and their maintenance workers, is they'll complete a job, they'll get something fixed, and they want to go on to the next thing, and not spend too much time with the paperwork. So often the failure information is not identified on the workflow, and in the long run, that sort of spotting trends in failures and working with good failure information is a way that you start to make. You can add in a lot of value from your data. You can find trends in failures, and you can sort of take preventative action rather than just find and fix the same fault again and again. And we consistently see that behaviour. It's just a fact that this sort of fail-fix mindset is still quite predominant. So one of the areas that we've worked and found we've been able to quite successfully train an AI engine without massive amounts of data is to be able to recognize the failures on a work order from the descriptions on a work order, and be able to prompt and interact with the user and who might be reviewing that work order before it's completed, and say, this is what we think it is. And you build up a level of confidence in that, and to a point where you allow that the intelligent worker just to run through the system automatically. So this is the issue where the area where we hit these issues of visibility of the model, and Gustav mentioned ethics, and the ethics of decisions. It comes into it as well, absolutely. So it's a question of visibility, trust, and the amount of training data. So data. It's always, you know, the level of training data in this practical world where data is not perfect. So the less we can be reliant on too much data, the better from a practical perspective, and in terms of the overall sort of performance of the system as well. So data is really important. Trust in the model is something we hear from a lot as well. So with some of the models, which are sort of, you think about sort of neural net and that sort of black box approach, then customers really do want to know, they want to have an understanding of that model, and this is where this sort of ethical and to have a reasonable appreciation of how that model of work is working is really important. So that's something where, from an IBM perspective, where we're applying a lot of effort into the visibility and looking for models which have visibility of their logic, and also allow something we hear a lot is the end users to be able to train the data and select the data. So maybe we provide a very simple set of data, trained data based on perhaps an industry standard, and then the customers can control. That's sort of almost, I've heard the term used from customers, golden records, or particular things that they have the tacit knowledge and skill to know that data is good data to train on, and you know, this is, it's interesting in our work. We found that actually the source of some of the errors that we've seen in when we did our early work around AI was data where we was often data. And initially, actually, one of the things that really started to fool us in our analysis, we were trying to work how good the software would be, the AI engine would be to identify a failure code. What we discovered when we were using a set of training data was that the person who had validated the data and said this is what it should be was actually incorrect in their judgment. It sort of threw us for quite a while, and actually in the end it was the AI engine that was telling us that giving us the right feedback. So data is really important, but I think this area of intelligent workflow is a promising one. And then we have that the other area of robotic process automation, and we've been, you know, working. We've embedded bots into our software in a number of areas, and but I think that from our perspective there, I think Gustav's point is a strong one about just the making sure that that's robust and it's repeatable, and you're covering as many options as possible. So I think robotic process automation has a place in a number of areas, but our focus from a technology perspective is around intelligent workflow, and one of the things that we sort of are focusing on is this sort of concept of trying to not go too far forward, so almost like a basic and advanced set of skills. So we'll have sort of more routine, basic digital skills and more advanced skills. So the more advanced skills might be linked into process mining and the more complex business processes, but really just starting to applying that Pareto principle, that we can make big leaps forward by making our customers at least take a good proportion of the routine activities away from them. So those are the sort of the basis of the technology that we're looking at, and some of the issues that we're looking to address as we apply this software. So I wanted to return with some to Chris Agaris before I close, and come back to taking effective action, and what Agaris calls double loop learning. And I guess this is pretty analogous to the first and second order cybernetics systems that Gustav spoke about. So I'm using the Agris's terminology around single and double loop learning. So in this case, the single loop is sort of similar to that sort of single loop controller. and then you have the outer loop, which is actually addressing the governing variables. So and Nagris and people like Sengi will talk about this mental map, the theories that those theories in use that we have, and from a human perspective. And interestingly, often the theories in use are different from the theories we espouse in practice. But those, how do you actually start to modify the theory in use rather than just taking more that single loop action? For those of you from more of a control background, this is sort of quite analogous to sort of cascade control strategies as well, where you have an inner loop governing your inner variable, your initial set point. But in some cases, particularly where you've got systems which have aspects of the system which move fast and other aspects of the system which move slowly, you have a governing and outer variable which is looking at the overall system. That's a sort of cascade control strategy, which is a similar principle. So Aguirre is a sociologist, of course, but I think I often come back and reflect on the on what his area of work can teach us. And if we think of how we might apply that from a cybernetic perspective here, then so some examples here, some practical examples. So from the single loop in a work management perspective, so what's our actual versus our plan? So we have our goal. We set out to do some work at a simple level, a work order. And the goal on that work order is that we do it to a certain cost and time and with a certain resource. And then one of the things we make sure with our systems is that is that the customer has the ability then to look at their actual what actually happened on this record at an individual record level, and so, for example, I have an estimate on that work order. My estimate was wrong, but you at least have that level of whether you achieved your goal or not. So, actual versus plan would be one example. I think the use of key performance indicators at a level, if you're looking at multiple records and sort of looking at a whole set of work orders, you can start to look at it from more of a key performance indicator perspective. On large groups of work orders. So what overall was my planned cost? You can be many customers running those sorts of performance indicators on their maintenance work, and of course safety related indicators as well. One of the things I would highlight there is that sort of trend we see with customers is the power of lagging indicators, of leading indicators as well as lagging indicators. As you start to be able to manage larger amounts of data, this is where potentially the automation and the AI come in terms of looking at maybe if you think about from a safety perspective, you may not have too many serious incidents, or the level of actual incidents is relatively low compared with the number of potential incidents or near misses you might have in an organization. So if you start to look at those near misses and be able to analyze the data there, you have very powerful leading indicators that can tell you that potentially there's a problem coming along that you can address before it becomes an issue. From a double loop perspective, then, so one of the things we'll take care to do is the transactional processes that we look to support is to provide that outer loop as well as the double loop, as well as the single loop. So, for example, root cause analysis to start to get down and find is what the immediate cause may be something that you can fix. Sorry, my estimate was wrong on my work order, but why was my estimate wrong? And maybe there's an issue of competence in the person who was estimating, or the estimating process is weak, or you're just estimating the wrong material. So those are things that if you can find and identify, that you can work on and take corrective action. So
a couple of minutes, Russell.
Yeah, just about there, John. And so, for example, here is the other areas on this double loop would be a sort of continuous improvement mechanisms within the software, management of change to be able to act on and implement implement change, and the capture of solutions and lessons learned into that process, and embedding knowledge into the system you capture as you're executing work. So as my final slide here, in terms of a future state, one of the things I tend to visualize the work that we from how we move into a future state is that it's this combination of the human mental model and the AI engine. So that concept of a combined mental model is something that I think that when we're explaining and talking about AI with our customers, that's something that resonates. Is that we're not introducing AI to replace the human brain. We're supporting that the human process in areas where AI works most effectively, and it has the potential to really take away some of those routine activities and allow customers to and allow the users to focus on value generating activities. And so it has that ability to do that, and also generate insight into data that is not always necessarily inside the human mental model. So for example, if you're doing a risk assessment, you have the tacit knowledge within the group of humans doing that risk assessment, but an AI engine can find and suggest things that may be out of that collective mental model of the people in the room doing the assessment. So, and finally, I think that my strong point is that for our vision here is that people, while we're applying this technology, people remain at the heart of the enterprise. And the best reference I could find here, John, was one quoted by you to Stafford Beer, and so that's my finishing point. That something I strongly believe in, that people remain at the heart of the enterprise.
Superb. Thank you, Russell. Do you want to unshare?
I will do.
Thank you. And then we can see all the happy smiling faces that are wrapped around the room, a number of whom will inevitably recognize people at the heart of the enterprise. And I think we all, I'd like to think anyway, that the vast majority of us would be supportive of that view. I'm going to come straight back in here. Steve Battle, wherever you're hiding on my screen. Steve asked a very question. We'll go back up a little bit. What does it say? What does the outer loop govern, with your opening question, Steve? Do you want to talk to your question, Steve, as a sort of starting point, rather than have me talk it for you?
Yeah, I was just commenting on the, I don't know how you pronounce the name, Agaris. So the diagram, when you first put the diagram up, looked like kind of an Ashby homeostat in a way, but I couldn't quite see what the outer loop was governing. But then your following slide kind of explained a bit, but it looked like a plan, do, check, act cycle. So I wondered if that's really what it was that you're talking about.
It's a little bit more than a plan, do, check, act, because a plan, do, check, act cycle could be acting on the single loop, and it might be sort of taking action on something that was not really altering the governing sort of the governing variables. So that double loop for me is something which is changing the. So for example, at one level could be changing the mindset of the people who are using that process. So they have a certain view of the way the process works, and actually that view is not really correct, and that's been the cause of the need to take action. So if you can sort of work to change an individual or the organization, not necessarily just an individual, but there may be a need to change people's perception of how a process really works. Or itself, it may be that the governing process around that that single loop is and the assumptions you make about it are wrong, and you find out they're wrong. So you actually, an example there of the plan, do, check, act might be where you find out that the business process, which is driving a certain loop, a certain process, the process is actually wrong. So you need to fundamentally change that process. So again, that would be a plan, do, check, act. You would act to change the process, but you're sort of acting at a different level.
Yeah, I thought that was kind of normally how PDCA was applied. how I teach it anyway. You know, that you kind of, you know, when you're running a project, you're kind of, that's your day-to-day job, but plan, do, check, act, that's part of your continual improvement process. So it's at kind of a higher level.
Yes, and that's
maybe
true
it's the same
to an
as your
extent,
double
that it is at the higher level. So I guess it's probably just, I think the double loop just sort of places a bit more emphasis on where that change is made. It's probably perhaps a way of drawing the analogy.
So there could be a comment there that the second loop is starting to look a bit like second order cybernetics, in the sense that the second loop is observing the operation of the first loop and acting to improve it. So the second loop acts on improving the first loop rather than acts on improving the problem. So there's a sort of an emerging hierarchy of
Yes, yeah, that's a good point as well.
But would you say a homeostat is second order though? I don't think so. Would you say though that a homeostat is second order cybernetics? I don't think so.
I wouldn't say anything controversial, would I, Steve? But the second loop is observing the operation of the first loop, is the implication of Russell's description. So the second loop, the governing principles thing there was acting as a higher order system to the operating system.
Yeah, and I don't have all the answers here, but I sort of have the feeling, and as I always talk to John about these problems, that cybernetics has something to offer here in terms of understanding how that all fits together.
It depends how you define observer as much as anything else, Steve. Is it part of the system, or is it an observer of the system, or is it an observer of the system that's also part of the system? I can feel Raoul sort of thinking out loud up there. Raoul, come in on the conversation. I see your hand up, Rory. I'll come to you shortly.
Yes, I think perhaps one point that has come all the time to my mind while I've been listening to both Gustav and Russell, is that I don't see much of an emphasis in organizational aspects. I see a lot of emphasis in processes. And in the latter case, in Russell's case, I can see a lot of emphasis in first and second order loops, but it is, in my view, much more interesting to look at first and second order learning. So in the first loop, what you're doing is learning about how to do better something. In the second loop, you are learning how to use the resources and the organization that you have in order to recognize what is a possible way to improve the situation.
Yeah.
So it's too much emphasis, I think, in information processes and not enough attention to organizational processes. Yeah. And that, in my view, reduces significantly the contribution that you're making.
Yeah, I think it's a really powerful point that you make there, actually. And I sort of was thinking about this a little bit, but I was preparing my presentation, because if you think of so many of the issues, and this is particular case in this our age of automation, so many of the issues are not necessarily process or equipment issues, but they are organizational, they're socio-technical network issues. And they systems often fail in very complex ways as well, due to those socio-technical networks. And so I guess I would acknowledge your points, and it's something that's very much on our mind here. It's sort of just, and I did start to think about whether I could get into that a little bit more, but in half an hour, that seemed a bit of a stretch for me. But I think you make a very powerful points and an important one.
No, that's fine. You know, I think the idea is to simply clarify in our own minds what is that we are looking for. And I'm glad that we are very much in line in this direction.
If I can come back in then, because behaviour was one of the words that I wrote down there. So Elena, I'm interested in your comment. I'm going to take Rory first, if I may, because his hand went up first, and then I'll come to you, Elena, to pick up your comment in the thread. So Rory, what's yours?
I don't like circles, so I'm not going to talk about circles. What it sounds like to me is it sounds like the building blocks of data from ACOF, which is what Tom Jackson spoke about in my first semester module with him. And that what it sounds like is that rather than being loops, you're just working your way up from data to wisdom. And that the single order loop that you talked about, the first one, the lower level one, is understanding. So why something is happening. And then the second order one that you're looking at, the larger loop, is wisdom. So you're using that information to make judgments. So that's what I've seen. That's ACOF's work. I don't know if anybody's familiar with ACOF's work here.
Yeah, I'm a little familiar with it, and I think there is an element of a hierarchy there. I think the loop becomes in because of the feedback, because there is a feedback loop in there. So maybe you have a hierarchy of feedback loops, but the basis of it is that you've got a sort of self-adjusting feedback loop in there. I think that's where the loop comes in.
Mm-hmm.
Thank you. So, Elena.
Yes, thank you for a very interesting presentation. I was interested in the how broadly the governing variables were conceived, particularly with regard to being in a turbulent environment. In the past several years, we've had to rejig a great many things due to COVID, and we're still seeing the reverberations there in supply chains. And so, I'm just wondering, how is that adjusted, and how explicitly are those governing variables and their range and boundaries identified?
Yeah, it's a difficult question, and it's one that we there is a bit of a tension, I guess, in some of the theory, if you think some of our customers in the way systems fail, in that you have the sort of the Jim Reason approach of barrier failures. So the failures are very linear, that one failure leads to another, that leads to another. And actually, and there are certain circumstances. If you think of look at pretty well any aircraft crash, aircraft investigation, there's always a series of things that happens, and the Swiss cheese model of everything lines up, and just on occasion there is a hole in the Swiss cheese and the accident path follows through there, and it's a linear model, and that works, and customers understand it, and but when you start to think of those governing variables in the more complex world, and that the interaction, it's not a linear model, and so then that model breaks down. But how do you start to sort of manage those governing variables from a system perspective, and help our customers to be able to be able to do that? And it's not an easy thing to be able to address. One of the things we've tried to do at a very simple level is to actually introduce the concept of human and systemic factors and human and systemic failure, to be able to identify and differentiate between failures which are more systemic. But as soon as you start to look at some of the theory of the systems theory and of complex failures, that being able to bring that in and systematize it into a system is difficult. So I wish I had a good answer for you there in terms of how you do that. But it's a factor, and in our complex world that is only getting more and more complex, there's more automation, there's more climate issues, supply chain issues, things just are getting more turbulent. And I keep my eye out and looking for ways that we can improve in that area. So if you've got ideas and thoughts on how we could address that, I'd be welcome to hear them.
The only idea that I can think of is, having enough real-time measurements that raise red flags that can be addressed quickly instead of after a time period.
Yeah, and it's getting those. And one of the things that we have been doing is embedding real-time capability into our systems and driving that into AI engines. But they involve quite large amounts of data, and then you store that data differently, and then you have to. It's sort of integrating that real-time data with the more transactional data and the sort of the system requirements. a difference, and you're moving quite large amounts of data around. So we have been doing that. We have like a capability we call monitor, and but it's then actually having the models and the ability, just not capturing that data, but being able to take what that real-time data is telling you and convert it into something you can take action on. And you know, there is work there around anomaly models that can do that, but in some areas it's still quite immature.
Yeah, well, thank you.
Thank you.
If I intrude at this point, Mr. Randall, you've had your hand up a while.
Yes. So firstly, thank you for both presentations. That was really good. Thinking about the single or double loop, first, second order, a couple of things, and also the data point you were making, Russell. So my current role is very much focused on input data quality, but one of the things we look for is that sort of double loop, second order. So in a data supply chain, I think it's similar to the point that Elena's making, is what feedback mechanisms exist in that, and is there good root cause, issue tracking, all that sort of stuff. The other reflection, again, on the kind of first, second, and possibly third, I've generally found when people tackle process improvement is to actually get the concept of that kind of third loop of actually what is the health of the process improvement mechanisms and behaviors and culture. So I've often kind of got into the zone of what's the third loop. So rather than dive in and do the process improvement, okay, how capable are we at doing the process improvement, right, and how do we better enable that?
Yeah, interesting point on that third loop.
So Jonathan works for Rolls-Royce, Russell, just so you're aware. So the aero engine's bit, so you have some shared space.
Yes.
I think actually Rolls-Royce use Maximo within your organisation.
We do indeed. I was looking at some Maximo data just early this afternoon.
Interesting.
Rory, your hand's back up again. And then I'm going to go to Gustav, come back to Gustav in just a minute.
Yeah, I'm going to wake Gustav up as well, because I wanted to redirect the conversation, because I remember when he was talking about influencing behavior and programs and services that influence behavior. And what I got from how he was describing it is that a purchase decision is behavior, because Amazon are trying to get you to purchase something, and that is trying to influence behavior. And maybe this is a stupid question, maybe it's incoherent, but would you define behavior to that extent, to that level of categorization, or is that too broad of a encompassing of behavior? Does that make any sense, or have I sounded extremely confused? Because I'm extremely confused. So if I've confused,
no, it's a great question, and it's not a stupid question at all. So when we talk about persuasive systems or persuasive technologies, then the common definition is that they are designed with the intent to influence people's behaviors, attitudes, choices. Like it's not just the actual behaviors, but it's also feelings, like how you everything that sort of precedes the behavior, like an intent to act, a feeling that sort of pushes you towards action. And there are several theories for action that I don't have them at the top of my head, but they're in the thesis. But theories for action, essentially, like how our actions form and how our intents to act form. These persuasive systems, they can target any part of that, and also design can be targeted at evoking certain feeling, for example, by adding a color to a button or changing a button, the color of a button, and on a tactical level, on a micro level, in a sense, to a macro level, like a system that consists of a series of, like for example, when you go through a purchasing, when you go to like an e-commerce site, then you start with sort of the first page, then you go to the product page, then you go to the basket, and then you check out, and then so there's several steps in that process that But it's an intentional process in a sense, so that there are desired behaviors. In UX, they talk about call to actions. That is call to action. So you could say that there is a macro intent in a sense of the system, that the system has certain processes that wants to lead you up to certain behaviors, and then there are tactics that are reinforcing reinforcing the behavior to that point. And what's also
so if you've got so let's talk about behavior as, say, a continual sequence of activities. The persuasive services that you've talked about are trying to not only influence the next decision, but influence the rest of the decisions afterwards and the rest of the decisions before. So extrapolate from that one scenario. That's what I've got from what you've just said. Does that make sense?
I'm not sure I completely get that, but yeah, I mean, behaviors are, they don't live in an isolated sort of point in, I mean, an action can live at the point in time, but then they have a history, there's something leading up to certain behavior, then there is consequences of that behavior. But then also, and tying back to the learning discussion, that there is also a learning both in the person that acts, the consumer or the one that make the purchase, what happened when I did this action. Like there's a learning, and then there's also a learning in the systems where they register. Okay, so what happened when you clicked here, so that next time you visit the same page, for example, then there might be a different response from the service. I'm sorry, I don't have a better.
Don't worry, Gustav. The point of these conversations is to frame the questions rather more than it is always to necessarily answer them. Conscious of time, Mr. Heald, you've had your hand up a while. Is that intentional?
Yeah, it is. It's Gustav may well wish to comment. It's mainly a reflection rather than a question, though, which is that, because what I took from his input was the digital part, and actually the emphasis that we could and should put on the design of systems, whereas I spend a lot of my time looking at how to diagnose and improve existing systems. And it struck me that you were talking about the pace of change and the coming of digital stuff, and how maybe cybernetics could be much more influential if we thought about the building blocks, I love your clay, that go into the design of a system that's kind of new. My reflection.
Thank you. I mean, I'm just surprised that I haven't encountered cybernetics before. I mean, I've studied economics. I've been working in the startup world for 10 years, and I haven't encountered cybernetics. And it's so strange because it's such a good language to describe certain patterns, certain systems that are goal-oriented, purposeful, such as digital platforms that are clearly designed with an intent that is a goal, a purpose. But it's I found it very sort of theoretical and difficult to get into, and I want to sort of reduce that barrier. I want to make it easier for people to learn about cybernetic concepts so that they can apply them, because as designers you need to be able to understand them to apply them, kind of. But thank you for your
no I agree with your point. We spend a lot of time looking at existing systems and diagnosing and trying to improve them, and actually the design part is something I rarely think about. From scratch.
I can see Gerard's got his hand up. Steve, you had yours hand up first, and then I'll come to you, Gerard. So Steve.
I'll do my question to Gustav then. So Gustav, right at the beginning, you made this distinction between science and design. And that kind of got me to thinking, in science, we suffer from this kind of, everything has to be written in the third person. There's this fiction that the scientist doesn't really exist. So does a similar thing happen in design? Or is it easier if you're allowed to acknowledge the designer to have this kind of third, second order view?
Thank you. Good. That's a good question. And So as far as I understood it, is that design has made a journey in the past decades. I mean, the design is relatively young as a formal discipline. And initially design, I mean, there was these attempts to scientize design, like to squeeze design research into the traditional sort of scientific ways of writing papers, of describing experiments, measuring, well, valuing research essentially. But that in more recent years, that design has developed their own epistemological grounds to argue for other ways of knowing. Christopher Frayling, for example, he describes research for design into design and research through design, where you can derive knowledge from the process of making and then document that is knowledge that you can't get from purely sort of theoretical studies. And also reflective practice as a source of sort of legit knowledge is also an aspect of design. And I think where design cybernetics comes in, I mean, as I mentioned, I was taught at the RCA as a fundamental perspective on design that cybernetics is also an epistemology. In a sense, there are epistemological rootings in cybernetics that resonates very well with what designers do, so that it's a way for designers to explain theoretically, ground their conversational processes in theory that is solid, and that is also grounded in a long history of discussion, both like from the roots of science and mathematics and other and all sorts of disciplines. So I'm not sure if that addressed your question, but yes, I think design is more open to more different ways of knowing.
Thank you. So Gerard, you're on mute. You're still on mute, Gerard.
My question is to Gustav. Very interesting contribution, especially because you refer to methodologies. So a methodology, I understand, is a systematic way to support something such that the outcome can be better controlled or can be improved according to previously identified criteria. Now, that means that sometimes you have one system which is might be more persuasive than another. One way of deciding between the two would, of course, be to evaluate one application. But in methodologies, there usually isn't, people try to refrain from evaluation because it's very difficult to go beyond this particular applications. So the question is, to what extent have you included, it's simply a question, it's not a critical question, but to what extent have you included testing procedures to make it possible while you are designing to choose this route or that route?
Exactly, like thank you for the question. So when in my reflective practice, I followed the sort of a stepwise approach, where I first did one round of practice, evaluated and followed this reflective practice loop of acting, observing, thinking, reflecting, and then acting, thinking, reflecting, and having three sets of or three steps in the development of that practice, where I also had a similar loop with the external conversations, so that each conversation led to reflections, provocation of new thoughts that were then built on in the next step, that were then built on in the next step up until I arrived at the state where I could draw some form of conclusions from the process. So that's there. So that in a sense, the evaluation part was built into the process. But one of the issues with this mode of research as well is the stopping criteria. Like when is the when is the process finished? Like when is it saturated? When is enough data collected so that I can say something? So I can say something about the outcome, and that is also discussed in a section in the thesis. But unfortunately I don't have that on the top of my head right now. And I'm not sure that I answered your question either, Mr. Dessau.
Okay, so ladies and gentlemen, thanks, Gustav. I think if I can quote Stafford Beer for the second time this evening, one of the things Stafford wrote, and I think it was in Heart of Enterprise, but I could be wrong, was that if your client needs an answer by Friday, then you give them an answer by Friday with the caveats around the validity of the answer. So the point about when do you stop, Gustav, is, well, it's as accurate as I can make it in the time you've given me to answer the question. So that's the answer you've got, and these are the caveats that wrap around it.
That sounds great. I wish I said that.
I've read a lot of stuff, and I wish I'd said a lot of it, but I was far too young to say it at the time he was writing it. So everybody, it is 4 minutes to 7. Can I say massive thank you to Russell and Gustav for some great contributions, and Russell in particular for highlighting the scope there is for cybernetics to improve asset management across a whole range of industries. And I shall look forward to discussing it with you soon, Russell. So Alena has put in the chat a note about there's some work, a review of Stafford's work at the Metaforum in June, which is a live face-to-face event. I've also put in the chat the link to our intended summer school in the middle of May, 16th of May. Delighted to hear from you directly via my email, which most of you will have, but I'm easy enough to find at President at. If you want to make a contribution or come to that event or whatever, just get in contact and tell me what you'd like to do, and we'll try and find space for both of those things. So in the meanwhile, can we say thank you to Russell, thank you to Gustav for great contributions, and we won't have one of these next month, because we will hopefully, many of us, be in Loughborough meeting face to face for the first time and discovering how tall, short, fat, wide we all are in real life compared to what you can see on a screen. But thanks a lot again, everybody, for turning up, and we'll put the video on YouTube and the website as soon as we can get it processed. All right. Thanks a lot, everybody.
Thank you. Everyone. Thanks. Bye-bye.
All right.